So this is the presentation that I delivered at the 56th Annual American Translators Association Conference in Miami in November 2015. It's all about the X files, so XML, XPath and XSLT. If you're looking for something that really gets deep into the nitty-gritty of X files, and this may not be the presentation for you, but if you're a translator or a project manager or somebody who's starting to work with translation tools and getting involved in these sorts of technologies, then I hope this is going to provide a good introduction. So let's start off with a quick explanation of what XML is. Now, XML is a software and hardware independent tool. It's only used for storing and transporting data. It doesn't actually do anything in itself. It just stores data that's used somewhere else, sometimes in multiple places. It stands for Extensible Markup Language. So actually why it's called XML and not EML, I'm not too sure. But the important part here is the extensible bit. So XML has rules, but it also gives complete freedom to the developer or whoever's put together the XML structure to use any sort of tagging and mechanisms that they want. There are no predefined tags as there are in HTML, for example. And this is where some of the complexity starts to come in, because we don't know what is actually going to be in an XML file when you get it for translation until you've got it and you can have a look at it. Whereas with HTML, you have a pretty good idea because you know what the P tags are, the break tags are, the div tags are. There's a lot of conventions and rules around HTML, and they're not there with XML. So when it's simple, something like this, where all of the text that we want to extract for translation is inside the elements. So you have Soldier Freddy, poem by Spike Milligan, is inside the title attribute. Is inside the title element. And then within the text elements, we have the rest of the poem. Soldier Freddy was never ready, but Soldier Neddy, unlike Freddy, was always ready and steady, etc. Very straightforward. And when you open up a file like that in Studio, for example, by default, it will pull all of that translatable text out in the elements and make it available for translation without you having to create any sort of custom file types at all. And the same thing will happen in MemoQ, and the same thing will happen in CafeTran, and the same thing will happen in Deja Vu, and probably a whole number of different CAT tools. It's nice and straightforward. So there it's easy. And if only developers always wrote their files like this, but they don't. Sometimes it might not be quite so simple as that, and very often you'll find that the translatable text has actually been put inside an attribute. So here we have exactly the same content for translation, but this time instead of being in the elements, most of it is in the attributes, the line attribute. And line attribute is not a standard term. This is just the name of the attribute that the developer has decided to put in, or in this case I decided to put in when I made this XML file. So then it's trickier. And if I open this up in a CAT tool, using the same examples, here the only thing that's extracted is the title that was in the title element at the beginning of the file. All of the attribute values are totally ignored because the CAT tool doesn't know what to do with it. And that's because normally you wouldn't expect translatable text to be in an attribute, but we know that this is what happens. And some tools can still handle these in a friendly way. So in Studio, for example, you can just add a rule, select attribute, and then pick from the details in the file which attribute you want. So in this case you'd pick the element text, and then you'd pick the attribute line because that was the attribute inside the text element. Nice and simple. In Deja Vu it does a similar thing. In fact, this works very similarly to the way MemoQ works, in fact. So here you've brought the XML file in, and it displays all the different elements and it as tags, and then it displays the attributes in the individual elements when you select them. And you just tick whether you want them to be translatable or not. So it's really straightforward and very simple. Not all tools will allow you that sort of customization. So CafeTran, for example, you're stuck if you use CafeTran. It can't handle anything other than text inside an ordinary element. But a slightly more sophisticated tool should be able to do that. But what happens if the file looks like this, for example? So now we're getting even a little bit more involved. And this is still a fairly structured example, I think. So here we have some additional text elements containing a bit of C data, and this might be information that you don't want to translate at all, but it's still in a text element. And if you did want to translate it, it's using C data. So this quiz could contain anything. For example, it's containing these tags, BR tags, HTML tags, and strong. These are things which normally in XML it's not allowed. That's why it's in the C data section, but the cat tool has to be capable of handling it a slightly different way. Or maybe there might be an alternative translation. So here we have the same text, it's in Welsh in this case, and that might be useful for a translator perhaps. Not Welsh, although I'm sure there are plenty of Welsh speakers who would find that very useful. But if the text that was in there was of interest to the translator, how do you get access to that? How do you make that available to them? Or minimum and maximum values. It could be that the text you're translating, this has to go into a display area or a display box which is of a particular size, and it could be determined by information that's written inside these minimum and maximum attributes. How do you cater for that? How do you get hold of that information and make it useful for you while you're working? Or translate yes or no attribute. So if everything was a text attribute, these two, for example, it says translate no. So how would you extract the text, or how would you extract from the text element only the text where there was not a translate no attribute? All tricky things that are very common within XML files, and translators, project managers have to be able to deal with them. Now, to handle all those kinds of things, we need to get a little bit more specific. And to do this, you use something like XPath. Now, this is nothing specific to Studio or MemoQ or DVX or anything like that. This is a World Wide Web Consortium recommendation as a web standard. So it's very easy to find information on how to learn this. But what we're going to do is look at some basics to get you started. So this is the main thing. XPath's purpose is to locate any part of an XML document. So it's like a map, if you will. And this will become clear in a moment, but that's all it's for. It's just a language to help you locate a specific part of an XML document. Now, there are rules around that. There's not a tremendous amount of theory about it, but there are rules. And it can take a little bit of digesting and plenty of time to get your head around all of that, especially the terminology that gets used, because it's not all something that is really clear and obvious to you. And when you read some of the things, it does make you wonder, what on earth are you talking about? It is worth learning. But you don't necessarily have to become so much of an expert that you understand all of that in order to make use of it. So if you're feeling a little bit like this, then don't worry. We've only got an hour for this presentation anyway. So although it's very important to know all of this stuff, if you want to be completely comfortable with XPath, and for our normal day-to-day needs, I don't think you do need to do it to know all that, then let's try and find a way of cutting straight to the chase. And we'll make him a bit happier at least. So here's the first clue. When we looked at how to extract an attribute and we looked at different tools and how they actually handled that, Studio gives you this little line, // text / @line. That is actually an XPath expression. And so it's been given to you straight away when you selected the rule. This is useful. And all it means is the text element is that first part. In fact, the two forward slashes aren't really the text element. The two forward slashes are just saying that's an XPath syntax for select that text element anywhere in the file. I don't care where it is. Just find me that text element. If I put a single slash, it would have wanted me to go back to the root element of the file. And then I might not have found anything if there was no text element at the root. The attribute is defined by putting an @ symbol in front of it. So what we've done is we've selected the attribute within the text element by using that simple little expression. and it's given to me there in Studio. So that's quite straightforward. But maybe we can just look at this in another way. So if you imagine a file path, because it is a little bit like a file path, and we all know how these work. So if you take this path, C users, P filk in documents, STL, etc., all the way to the file, and you can see from the image that the structure is structured. It's like a cascade all the way down through the file. And we know how to write with the location of that file, and we know how to work in Windows Explorer in order to work our way up and down that path to get to the location we want to. Well, XPath is exactly the same. So the slashes are going the opposite direction, but it's the same principle. So that's // text. If you remember, I told you that the // just means find me that text element anywhere within that file. If I wrote that out in full and I wanted to get to that @ line, or I wanted to get to the line attribute, then I'd have had to look at the whole of the XML file, and in actual fact it would have been written as / title verse1 text @ line. So there's the path in order to get to that attribute. And if I stick that on the end of the path to the file and just drill down further, you can see it makes complete sense, because the structure of the file is exactly the same way. All I'm doing is finding information within that structured path by using the same sort of syntax as you would if you were just looking for a file. So it's fairly straightforward. Now, to do that, to find all of these things, there are plenty of free tools about, so I thought it would be worth a look, particularly as I'm going to use one of those free tools for a lot of this demonstration, a lot of this presentation, just to look at a couple. So there's one here called XML Tree. This is an open source software. It's licensed under GPL version 2. It's very simple. All you do is open the XML file, and on the left hand side of the window there, it lists out all the different components, all the different nodes. So you've got the elements, the attributes, the text inside, or the values. You've got comments. I think there's 7 different types of nodes, and whichever nodes are inside the XML file, they're listed there on the left hand side. And when you select one, the XPath expression that to get to the one you've selected is displayed here. So I've picked this text, and it's told me the XPath expression is go through the XPath element, through the simple element, and then look inside the value of that simple element to get at the text. So that text with an opening and closing parentheses, that is an XPath syntax. And what it's also doing is, in this window here, it's displaying the results of all the different text that is found through using this expression, because there's lots of simple elements. In fact, there's 6 simple elements. So it lists all the different values of text that is found within those six simple elements. Nice little tool. You can't type expressions in or anything like that, but it can very quickly give you an easy way to find basic XPath expressions for different locations in your file, which can be quite a time saver. And I thought it would be worth mentioning at this point, if you happen to be a MemoQ user, MemoQ have built into the multilingual XML file type a bit of capability to do exactly the same thing. So you can select the specific node that you want the expression for, and it will give you the expression. It works a little differently because it's giving you what's called a predicate. So it's giving you the number or the predicate, telling you whereabouts within the XML file that particular node is situated, whether it's the first instance, the second instance, the third instance. That's what the 1s and 2s are for. And then it has a number of different features associated with the multilingual XML file type. So this is available in MemoQ. It's only available on that file type, but it's a very nice feature. Nice to see it in the tool. But if you don't have MemoQ and you're not working on a multilingual file type, then you might want something else. And so here's another tool. This one's called XML. I don't know if that's Choir or Queer. I'm going to call it Choir, XML Choir. This is a freeware tool, so you don't get the code with this one, but it's like you can pick it, take it, share it with your friends. This is quite nice because It gives you a lot more information than the previous tools. This one allows you to type an expression in and it will display within the XML file what it's actually found when you type that in. It also gives you all the different all the different results that are found from using that particular XPath expression. And as it gets more complicated, there's a lot of other features around the different elements, the different nodes that are available to you, and you can just select them from this window down here. Requires a little bit of work getting your head around this one, but it's a very cool tool. But the one I'm going to use today is called XPath Visualizer. This one is, again, it's open source, it's completely free under the Microsoft public license. It's a very nice tool, this one, and this just allows you to very simply open the XML file, nice and simple, and it's even pretty printed for you. And you just enter your XPath expression into this top window here, and it highlights all the results for you in the XML file. So it's very easy to see what it is you're finding. I really like this tool, and this is the one that I'm going to use while I'm going through this demonstration. So let's just take a look at a few XPath examples then, so we can try and understand the syntax a little bit and get our heads around how this works. So first of all, we'll start with a few basics and just look at element nodes. So there's three different expressions which I've shown here. The first one is a / star. Now star is something we haven't looked at yet. The star symbol is a wildcard. So this basically just says extract all the elements wherever they are. That's what the two / is for, if you remember. That means wherever they are. The second one is a bit more specific, and so I'm saying there, find me the simple element wherever it is. And you can see that it's going to find 1, 2, 3, 4, 5, 6, 7 different elements. And then underneath that, I'm just going to look at one quick example of where here I'm being a little bit more specific, and I don't want any simple element. I only want the simple element that is within the nested element. So the nested element and the simple element, these are just names that I've given in my XML file to the different elements. So we'll start off by looking at those. So if I just flick over to my visualizer, here it is. The first thing to note here is I've got nothing in the screen. Now when you bring the tool the first time, and there's not very good instructions for this, so you just need to know that you have to press the Alt key, and when you do that it brings the menu up, and then you can open your XML file, and when you do, it opens it up and looks like that. So it's really nice. And that first expression we looked at was the star symbol, so you can see this is just opened up and it's highlighted the entire file, and that's because the 37 different elements that are within that file, or of that 37, I'm opening the first one here, XPath. If I click on this little button and go forward, then it finds the second one. It skips the comment, but it's showing the simple element. And when I move on to the next one, now I'm seeing the nested element, and within that, the simple element. So you can see I can just go through there and find exactly what it's finding each time. Very nice tool. So that was a nice simple one. If I just wanted to look at the simple elements, I can change and get rid of that star and just type in simple element. Now if it doesn't show anything, as this one is not, just a point to note, and I think it's a little quirk of this tool, is it tries very often to throw a namespace in there, which throws things off. So if we just delete the namespace and come back to here and press the return key, then it works. So I've highlighted it again, so it's found all the simple elements for me. There are 7, 1, 2, 3, 4, 5, 6, 7. Yeah, or in fact I could have just gone like this, couldn't I, just to show you. So that's straightforward and nice and simple. If I wanted to see only the simple element inside the nested element, so you can see this second one, if I make that red, this second one here, this is sitting inside the nested element. So if that was the only one of those that I really wanted to translate, then I would simply add the name of the element of its parent element, this one here, nested element, in front of it. Like that, so nested element. And when I do that, I'm only selecting the nested element. So you get the idea. It's just the same as selecting files, but it's like files within, or it's just like working with files in Windows Explorer, but it's files within this XML structure. That's the way it works. At least when I think of it that way, it makes it easier for me to understand it. So I'm assuming that it's going to be the same for you. I hope so. Okay, let me move on to this next one. So that was elements. Let's take a look at some attributes. So the attributes, you can see from the image down there, these are normally within an element. So this first expression, this expression is saying, find me all of the elements anywhere in the file, and then find me all of the attributes inside all of those elements. So just to extract all of the attributes. The second one is saying, just find me the content of the translate at attribute. So an attribute called translate at. So let's take a look at those two examples. So the first one, we delete that, was a star symbol here, which selects everything, as we know, a / for the next bit, at symbol, and then a star for all of the elements. And you can see that's immediately gone through and it's selected all 10 of the attributes within the file. So I have that first one, translate equals yes, then translate equals no, then the translate at, then translate yes, translate at, and then down here I'm finding those 4 length specifying attributes, maximum and minimum. So very cool. That was pretty straightforward and simple. And if I just wanted to find the translate at attribute, this works just as you'd expect it. One thing to note is, if you're putting this into Studio, you can just do that, which is perfectly valid, and Studio will find it. This particular program requires that you add the 2 / at the beginning. So when you do that, then it will display it. So in order to help you when you're finding things, it's just a good thing to remember that little quirk of this particular tool, or maybe it's a quirk of Studio, perhaps this tool is doing it correctly. But Studio doesn't need that. It would probably work if you put it in, but it doesn't need it. Okay, so that finds me just the translate at. And another useful thing after that is that if you want to, the pipe symbol allows you to string expressions together. So if you wanted to find more than one thing, so if I come back to my visualizer for a second, so I found the translate at there. If I wanted to also find, say, the maximum ones, I could put a pipe symbol in that, another / at, say, max. And you can see now what that's done is it's allowed me in one expression to find the translate ats and the maximum at. So I can go through it like that with the red. So there's the first 2, and there's the third 2 down the third and fourth one down the bottom. So you can string as many as you like together using the pipe symbol, which is pretty smart. So I could have the minimum as well, and then I get all these minimum ones down the bottom. So this is quite useful, because if you're using a tool like Studio, for example, where you might want to apply a bit of document structure information, a bit of context to the element you're extracting, if you can string them all together like this, then this allows you to add one piece of context information to that single rule, instead of having to add the same information to 3 separate rules. So it's quite a useful feature to be able to do that. That pipe symbol is very useful in a lot of tools, regex for example. But I'm going to move on a little bit further. But before I do, I just want to explain the concept behind XPath again, because I'm about to move into something which is a little bit more complex, and I was trying to think of a good way to make it easy to understand. And the way that came to mind was to consider the way a sentence is structured. So for example, I've got this structure here. My clever dog Regex barked at the mailman. I don't actually have a dog called Regex, not yet. But thanks to Fleur, I'm going to. So, my clever dog Regex barked at the mailman. That first part of the sentence, my clever dog Regex, that would be the complete subject. The second part of that sentence could be described as a predicate. And the predicate, when you're talking about language like this, expresses what the subject does. So, my clever dog Regex barked at the mailman. And the predicate itself is made up of a couple of things. It always includes a verb, and it can also include other descriptive words. So the verb will be barked, and the descriptive words R is barking at the mailman. Really simple, and I think everybody understands that. It's language, that's what we do for a living. Now, consider this. I've taken the same sentence and I've marked it up in a different way. And this is basically how an XPath expression works using predicates. And we call them predicates with XPath as well. So there's nothing new here for you guys. So the node test here, this would be the complete subject, but we just call it a node test because we're testing for the node. We want to know which element it is or which attribute it is. And the predicate, this bit, which is just narrowing down that node test and being a little bit more specific about what we want to do with it, the same as with language, this is written in this way, always inside square brackets. Now within that predicate, here the verb that I used in this sentence, barked, is equivalent to a node. Now with XPath, a predicate does not have to include a node, but it always has to include the other descriptive tests because that's the whole purpose of the predicate. It's narrowing down the test from the original node. So if I look at it like that, it helps me to get my head around it and I can really understand it quite well when I think about it like that. And again, I hope that makes some sense to you, but I'm going to look at some examples of how that works and perhaps that will also make it clear as we go through a little bit further. So take something like this. So I'm going to use this particular XPath expression to extract any text in an element which has this attribute value. This attribute value being yes. So I'm saying with the // star, I'm saying look at all the elements, and then I'm being specific with the predicate, and I'm saying within those elements, look for an attribute, that would be the verb, @translate, and then the testing bit to really specify it is that it must equal yes. So look in all the elements in the file, look for the ones which have an attribute value of an @translate attribute value of yes. And if you find those, extract them for translation. So it should just find within that XML file 3 different segments, if you like, segment 3, segment 6, segment 8. So if we go back over here to my visualizer and I delete this and I replace it with my // find all my elements, so it's done that. Then I open up the square brackets for the predicate and I say @translate, oops, let me move that mouse out of the way, equals yes. Now I've used single quotations here. You can actually use double quotes as well. But if you start using style sheets a lot, you'll find that very often the code within the style sheet uses double quotes because often you're moving to HTML. And if you use double quotes for that and double quotes for the XPath when you're selecting different parts of the XML file to go in your style sheet, that can cause and lead to confusion. So you can separate the two by using a standard convention. And for me, I always use single quotes in the XPath and then I don't get that kind of a problem. But you can use either. So if you're wondering which one is the most important, they both work, but it's a good idea to make sure that you only use one for XPath and something else for your HTML and your style sheets so you don't get overlapping codes. Now, if I close the bracket, that immediately narrows it down, finishes the XPath expression, and you can see that that has found 3 different values for me where the translate attribute was yes. So here we go, is the first one. And it's pulled out the element for that. So the element would be number 3, which is that value, number 5, and number 8. Really straightforward. So that made complete sense to me. If I move to the next one, if we just remember what we did before with translate @ where we just found the value of translate @, what I'm going to do now is take an example of where I use a condition to conditionally translate that same attribute of translate @. And to do that, I'm going to use @translate equals no, but inside a bit of syntax where I'm saying not @translate no. So basically what I'm saying is look at all the elements. That's what the // star is for. and then make sure you only look at the ones that do not have @translate equals no. Actually, and you can see I've broken a golden rule there, because here I've used double quotes. It would work, but I'm going to change that when I do the actual expression. I should have used single quotes for that. I'm going to change that for the actual presentation I give. And then once you've established that particular rule, so you've established that you've looked at all the elements, you've checked against it to make sure that none of them contained translate equals no, and when you've established which of the elements fitted that part of the rule, then you're going to translate the @translate @. So that not @translate equals no is actually exactly the same as @translate equals yes. But I just wanted to show you how you could reverse the selection by using this command not inside a pair of round brackets. So if we move back over to the visualizer, I know it all gets a bit geeky and hard to get your head around, but if we come back over here and we had this, we started off with, let's just remind ourselves with, whoops, I need to have the @ symbol because that's just an attribute, that one. So @translate @. So @translate @ found two attributes for us, 3A and 5A. What I want to do this time is only find 5A. And I do that because the translate attribute beforehand, this one says yes, this one says no. And so I can do that two ways. Let's just do that so that we can understand it better. So I'm going to say, come over here at the beginning. So I'll have my star in the beginning to pick everything up. Then I'm going to open my quotes, open my square brackets for the predicate. Put my / at the end there. Whoops, sorry, that's a little auto hotkey that added that PF in. So now I'm going to write my predicate in between those brackets. So I could write, just in there, I could write @translate equals yes. And then it would only find 5A. But I could also use, just to show you how this works, the reverse of the translate equals yes, and I could say not translate no, which should give me the same answer. So I can say not, and then I need to open these little brackets here and then close this bit in brackets because this is the way the function works. And I change that to, you see actually it's picked up no because I've said don't equal yes. And so then if I change that to no, it picks up yes. So it's the opposite. But it's another nice little feature to know that you can use this not command in order to take everything apart from the information that it was actually supposed to find. It's just another way of narrowing and filtering things down, but it gives you some idea, some context about how the XPath is working. So if I go back over to my slideshow and I move on again, so I look at functions and operators. Now we've already looked at a function already, which was the not function. This time what I'm going to do, and this is a really clever function, I like this one a lot. What this allows me to do, and this is the text function, so text open bracket, close bracket. This allows me to extract the contents of any segments that contain the text I'm looking for. And in this case, I'm looking in that file for anything that contains the text ATA56. Now there are 3 segments in my XML file that fit that criteria, segment 1, segment 9, segment 11. So let's just look at those quickly. So if I go back over to my visualizer, let's get rid of all this. And in the visualizer, let's type the expression in. So we start with our // star. This selects everything. Then I open the square bracket to start the predicate. And what I'm looking for is only those segments that contain the text ATA56. So I can use this contains function, contains. Then I can open up the brackets again. So I'm actually nesting functions here. So I open the bracket, and in here I'm going to write text. This is the command, text, open bracket, close bracket for the text. Then a comma, this is just the syntax to use. And then inside quotes, I need to write the text I'm looking for. So I want to find ATA56, close the quote. Then I need to close the first bracket, which is that round bracket, and then close the square bracket, and that finishes it off. And as soon as I've done that, you can see that it's selected 3 nodes, 3 simple elements. Each one of these is containing, and they're all different elements. This one is simple element, this one is any text, and this one is 6. And it's selected these because of the fact they each contain ATA 56, ATA 56, ATA 56 in there. You can see I have one here that contained ATA 55, which it didn't find. If I wanted to find that one, I could change that to ATA 55, and then it finds that segment for me. So this is really powerful, and this is a question that comes up quite a lot when I talk to people wanting to know how they can extract the text for translation, where it's a really complicated file where the elements are repeated all over the place, and the only way to identify the correct text is because there's something written into the text itself, and people don't know how to get at that. XPath allows you to do that. Very powerful tool. If we go back over to the presentation again and just take another look at an example like that, it can be even cleverer than that. So we probably understand what we're getting at here now. So here we're saying look in the condition element. So instead of looking in all of the elements, which we did before with the star symbol, this time we're just going to look in the condition element. And then inside that we're going to narrow it down by looking inside the answer element and see whether or not there's a text value inside that answer element of 42. And if there is, then extract the text from the extract element. I've made this difficult to understand by using the same words for the element names themselves, but this will make more sense when we go back and we look in the visualizer. So let me go back and have a look. So we come back to here. Let's just wind back a bit. So we're going to look in the condition elements. Okay, which is like that. Oh, and I think, remember I told you about this little namespace thing? It's popped up again. I don't know what it does that makes it do that. So let's just look in that condition element. Doesn't want to play the game. Let's just type it out again. So / condition. There we go. If you have these problems with this particular tool, I don't know why it does that, but they're pretty easy to resolve just by removing the namespace, retyping it again, and it all seems to work again. So I take the condition. I've now been able to extract 3 lots of condition elements. The first one, the second one, the third one. You'll notice that actually it's only that second one that contains 42. So this is the answer to the life, the universe, and everything. 42. But I only want to extract from this extract element, not from the rest of it. So not just conditions. So what I need to do now is I need to come in to build my predicate. So what I'm going to say now is look for the answer element. So the answer element is this next one containing 42, and then look in that for some text. So there's the command or the function in XPath to look at the text inside the answer element and see whether or not it equals 42. So I type the 42. Then I can close my predicate. Now at that point, you can see now I'm only highlighting the condition element because this is the only condition element that contains 42 in the answer element. So that worked. But all I want to do is extract the answer to the life, extract the answer to life, the universe, and everything. So to do that, at the end of this, you probably guessed it by now, all I need to do here is just type extract. And it's pulled out the information from the extract element. So you can see by using XPath, you can narrow down where you're actually getting to within the XML file in a really logical, straightforward way to be able to get at just the information you want to extract for translation in a more complicated file. It's very cool. I keep saying that it's very cool, but I do think it's very cool. But let's take a look at this one. So this one is all about conflict resolution. So we've got a happy dog and a happy cat sitting together again now. The conflict for us is namespaces. Now namespaces are pretty good, and they provide a way for a developer to avoid element name conflicts. So if you had a group of elements that were nested within an XML file with the same name, but actually the developer only wanted to use part of them in one part of his application and a completely separate one in another part of his application, the way he might do that is by using namespaces. The problem that gives for us is that if we don't understand how to deal with namespaces, and they add a degree of complexity when you're handling XML files, it can mean that you're not actually extracting all the text that you want, and sometimes it becomes very hard to understand why. And even harder where there's been a lot of namespaces used, because you have to write lots of rules, including all the namespaces, in order to pick those up. So XPath has come up with a really clever way of dealing with that, and they have another function called local name. And this allows you to just completely ignore the fact that there's a namespace and extract the text you want from an element anyway. Very nice XPath feature, which if anybody has ever had problems with this before, I'm sure they can relate to this. So the way it works is we first of all just take the strong element. What you can see we're getting down here at the bottom is we've extracted two elements. So the word guitar inside this strong element and guitar inside this one. What we've missed out is this one. And the reason it hasn't been picked up is because of this namespace that's included within the file. So I would have had to specify within my XPath expression the name of the namespace. So the way to get around that is if I come inside here, first of all, just look for all the files. You could be more specific to begin with, but I'm going to use this just to keep it simple. Let me just delete the word strong so it doesn't confuse things. And then we type in the local name function. So local #name, open and close the round brackets. And then I want to say that local name and then equals, inside single quotes, strong. Like that, and then close off my predicate. So now what we're getting, if you come down and look at the bottom here, this time we're getting the first one, the second one, and the third one. So we're picking up all three, because using the expression this way has allowed me to just pick up the name strong, or the element name, or the node name strong, and completely forget about or completely ignore the fact that we've used namespaces. So just use the local name. So a very cool feature of XPath. There are some other interesting little features that you can use within the tool. So here Studio, for example, makes use of XPath all over the place. So here I've been able to use XPath to take the content from an XML file as the descriptive text for a particular column in SDL Charter Studio. So where the XML file started off like this, the root node had a bit of text after it, 8856 Miami. And I would be able to, if I chose to extract that information and include it in the document structure information that gets held at the beginning of the file. So maybe it might be quite interesting just to take a look at that and also see how some of these things work within Studio itself. So if I come to Studio for a second, and if I come over here, so I've created a file type already, but it's got no rules in it apart from one to say don't translate anything. So that // we know that means select everything, but then make it not translatable. So if I just open my nitty-gritty test file now, there'll be nothing passed in Studio whatsoever. If I look at the file type, the file itself, if I come down to nitty-gritty file, let's just decide what we might want to pull out. So if I pull this file up here, here's my file. So let's say, for example, I just wanted to pull out, let's say I wanted to pull out the length attribute down here. So let's just pull out the text for this length attribute. And we're going to add this, a bit of structure to it, and add that content in the XPath element, exactly as we just saw in that example. So in here I can add a rule. So we add a rule, XPath, length, and we just make that always translatable. Now if I click on that, and I click on this, and I just open that file up, nitty-gritty, this opens the file up for me in Studio, and you can see I've just pulled those 4 sentences out. And if I go back to my XML file, as I scroll down here, it's these 4 sentences here that I pulled out, because this is the only length attribute in the file, and I pulled out this translatable text. So that was pretty straightforward. What I want to add to it though is this information here in the document structure. So I can see it's in the XPath element. So if I just come back to Studio here, close this, go back to the file type, edit it. Down here you can see I have structure info. So I can edit this. I can add a rule. I can make it a custom rule if I like. I'm going to make it a custom rule, and I'm just going to call it my, or I can give it a custom structure. I could pick a default one if I wanted to. Sometimes people do that, but you can use whatever you like. So I've used one and I've called it XPath. And what I'm going to do is I'm going to take the description for the content of this structure, rather than just type something in here, from the XML file itself. And so I do that using this, the XPath rule we just discussed. Whoops, help if I spell it correctly, XPath / and then the text function to extract the text from that XPath element. I could change the color and the formatting, but I won't do that. I'll just select OK at this point. I can show it in Document Explorer if I want to. That might be interesting. I can say show the element content, so I could do that too. Just click on OK and OK. So there's my context now. And now when I open that file up in Studio, this time I see a couple of interesting things. First of all, I see the element content over here, and I can navigate by this too if I wanted to. So it might be interesting. Probably not, because I've actually extracted the content itself. But if I wasn't, if I was pulling some information from other things, I could still display the content in here, which might be interesting. And under the document structure itself, I've got that additional information I pulled out, HA 56, Miami, Florida. So pretty cool. So I can take some information from that. Let's go back to my presentation. Another interesting use case for XPath might be if you want to take attribute values like this to control a verification check on the actual length of the information inside a segment. So when you're doing the translation, it could be that the developer has added length restrictions based on the size of a Windows box or something like that in a piece of software, and you're translating the XML that's used to populate the text in a software application. So here you can have a dynamic verification check against the actual lengths specified in the attributes. Pretty straightforward. I'm just going to specify the actual attributes. So my XML file, the attributes I've given them, they could be called anything, but I've called them maximum and min, which kind of makes sense. And then there are different values specified in there. It could be 4 different values. So if I just go back to Studio, I'll close that again and go back to the rule. So I'll use the same rule because it's part of the length element. And in this case, I'm going to go to the Advanced tab, and in here you can see there's a length restrictions possibility. So my minimum length is going to be @min, because that was the name of the attribute containing the minimum value, the minimum length value, and @max, which is the one that contained the maximum value. Very simple. And I click on OK, and now when I open the file up, it looks like this. And you can see the document structure column has changed a little bit, and as I move down over them, the LN stands for length restriction. And you can see it's showing me the different values of 50, 50, and 5 for the minimum value, and the first one was a 5 as well. If you click on them, you can see there's two. So the code is actually LN, but the plus symbol is near it to say that there's more than one code, more than one value in there. So I already had XPA was my other one. And the way this works, if I just copy the source to target there, this one had a restriction of 5 characters on there. So if I confirm that, I should actually get an error message on that one, which I have, saying the paragraph unit exceeds maximum allowed length 5. So that was correct. And this next one is too short because I put a maximum value on it, or a minimum value on it, sorry. So if I control insert and do that one, I get an error on that one too. And this time the paragraph unit is shorter than the minimum length allowed. The current length is 22. So pretty cool. These other two should be just fine. So that one's fine and that one's fine. And you can see actually in the messages box, I've also got the same error messages in my messages box, all come down as a result of drawing information from that XML file using XPath, which is pretty smart. I really like that capability. So other examples of where you could use XPath within a tool. I would love to show you something in another tool there, but I'm not aware of another one that has that particular capability other than Studio, STL Studio. At the moment, that may change in the future, who knows. Perhaps I've just given somebody the idea to add it into their tool, who knows. Now there are lots of functions and lots of features within XPath. So I'm not going to go into more of those now. What I am going to do is just point you to this website, which is the World Wide Web Consortium's recommendation for the XPath language. It's version 1. There is an XPath 2 as well, but I've only been showing you today things within XPath 1. Actually, the things I've shown you today are also in XPath 2, but Studio certainly only supports XPath 1. I've no idea about other tools. I think most tools today still only support XPath 1. If you can find them with 2, it's really good. There's some very nice features. XPath 2 allows you to use regular expressions inside the XPath, so then you can really get geeky and really get smart. But there's quite a lot you can do, as we've just seen, within XPath 1 alone, and you'll find all the information about features and functions and things inside that document, so it's well worth a look. Now the last thing I wanted to talk about today, and I'm not going to be spending so much time on this really, is Stylesheets and how they can be useful and where the sort of technology we've been looking at comes in. So by Stylesheets we're talking about XSL, which would be extensible stylesheet language. XSLT is an extensible stylesheet language transformation, and this is where you use a stylesheet to change the way the information inside an XML file looks. So you can see I've got my little XML file added to a stylesheet, transformed and giving me a nice catalogue. Certainly a better way of looking at things. Now the really cool thing about this is that XSLT uses XPath. So now that we know all about XPath, we can take a look at how this sort of thing might work inside a stylesheet. So take a look at this, for example. Here we can see we've got a little bit of XML code at the top. So we've got the opening definition for the file, followed by dogs and then breed. These are the two elements. And if I was creating a match, a template match within my style sheet, I can tell the style sheet to use the information within particular elements using XPath. So my first template match might be to write an HTML file out of the information in the XML based on information coming within that breed element. And so I can use XPath to specify that breed element just like that. If I wanted to select specific information inside the XML file to include within my HTML file that I'm converting my XML to, I could do it here. So for example, I can use this the XSL value of and then select to select specific values, and those values are selected again by using XPath. So here's something we didn't look at before, but you can use XPath to select a comment using the comment open brackets close brackets syntax. So here I've got breed characteristics and vital stats. This is the first comment in the file. Vital stats is the second comment in the file. So by adding the 1 and 2 predicates at the end of it, this is actually a shorthand way of writing position open quotes 1. Oh, sorry, position open brackets 1 close brackets. I can just write it like that. And this is saying pick the first one, and then the number 2 says pick the second one. So I can use the information in the XML file inside those comments inside the HTML file that I'm converting it to using the style sheet. And there's another quick example. Again, I'm selecting the value of an attribute inside an element called DC1, so the score. And again, it's just XPath. So I'm not really explaining to you how to create a style sheet here. I think that's another subject on its own. I don't have enough time for that within this hour. But I just wanted to show you how within that style sheet, the selection of the information from the XML file to use in the style sheet is all done by XPath. So once you've learnt the XPath, you're well on the way to the next part of improving the experience for a translator. And what I mean by that, if, for example, you were to open the XML file in MemoQ and look at the preview looks like this. And so without using a style sheet, the preview is just the bare bones XML. which is quite useful, I suppose, because you can see everything in the file while you're working and you know which bit you're working on. But it's not as nice as something like this, where you're working and you're seeing the actual layout of the file, the way it would be distributed. These little placeholders here are images. This is just because at the moment MemoQ won't render the images unless they're specified by a URL inside the XML file, and in my test example they weren't. If I look at it in Studio though, for example, here I've got Studio, and same, exactly the same as MemoQ. The default will just show me the XML file and what that looks like. Useful, but not as useful as that. And in Studio, when I do that, I actually get the images as well, because there's no restriction around how I would use the images here. But it gives you a far improved experience. So I'll just show you very quickly how that works. And I'm just going to do that in Studio. So if I come back to Studio here, I just go to my file types again. So I've got a file type up here called dogs, which I've created already, and there's a preview part to that down here. And so all I'm doing there is I'm selecting a style sheet and then adding any ancillary files that go with it. So I had a bunch of images that were associated with that, and these images are called from the style sheet. The style sheet itself is pretty straightforward. Let me just close that file because I don't want that one open anymore. And if I just here's my XML file here, all about dogs. There's lots of information about dogs, and here's my style sheet here. So the style sheet, all I'm really doing is I'm setting my template match, and inside that I've created an HTML file. So all the style sheet is doing is it's converting information that I call and writing it as an HTML file. And I call it using these XSL value of select functions. So I'm taking the type element. So for example, the type element would be Cairn Terrier. So I'm saying write into my HTML file, and the heading 2 in blue font, the type element. And the type element would be a Cairn Terrier, and then it would be a Bull Terrier, and then it would be a Labrador Retriever, and then a Siberian Husky, and then a mutt. So really quite straightforward. And you can see I've used XPath to select all the information that has been used in my style sheet to create the HTML file. So it's dead simple, and then all I've done is I've loaded that into Studio. So then when I open the file in Studio and I open up my dogs XML and I say OK, it opens up like this, and when I preview it and generate my preview, here's my XML file looking a whole lot easier to understand in real time, because it's showing me how the file is laid out nice and easily. And for a translator, this is far more contextual and gives them a better idea when they're translating it, to help them make sure that they're getting the right translation than just looking at the bare bones text or the bare bones XML. So pretty smart. So that's it. That's all I covered on the presentation. Obviously, I can't handle any questions in this particular version of it, but I hope it was useful. And if you did attend the presentation in Miami, thank you very much for coming. And I hope this serves as a useful reminder to anything that you learnt on the day. Thank you.